Welcome back, everyone. Let's continue our topic on encapsulation and generalization as a part of incremental development series. Now, in our previous video, we actually created a logic. We developed a logic of printing a single line for a multiplier of a given number. Then we encapsulated this logic inside a method block. We call this method block multiplication line. Then we went into and generalized this method by adding a parameter which is then used inside our logic to update the logic accordingly. For example, previously we had to pass in a number inside the loop, and this loop would generate the line for this specific number. However, after generalizing this logic here, this whole method here, we actually allowed the method to accept a parameter from a user when the method is being invoked, and then we assign this parameter instead of the multiplier that would have been manually assigned. Now our code is generalized. It is also called flexible, right? Now our code is flexible. In this video, we are going to tackle the challenge that we have here for avoiding the repetition of calling this method 10 times in a row to be able to generate a multiplication table like this, right? Now, when you have to do the same thing again and again repetitively, you always think about loops. So far, we have seen while loop. So let's look into this dilemma we have here, and let's think about how we can challenge it by using a while loop. So let's do this. Int number of call is equal to 1. So we say that we're going to call from 1, right? We're going to call this method until it gets to, let's actually add comment here. So let's say we have all these calls to this method until it gets to 10, right? So while the number of call or invocation, as you want to call it, is less than or equal to 10, call this method and call it for the value of number of call. That's it. Does this? And okay, what we're forgetting, do not, actually I always say start this first. Basically change the condition, update the variable that your condition is being checked for. Okay, creating infinite loops is very easy. To avoid doing so, always look into your variable starting point, look into your condition, and make sure you update your variable in such a way that your condition at least becomes false at least once. If you're starting from 1, you're going to go up to 10, because 1 is going to have to become less than or equal to 10. Then you're going to increase the value of 1. Do not forget this line, otherwise you got yourself into a nasty infinite loop. Now, great. Let's do this. Let us actually remove all these unnecessary calls, and let's just run this logic inside the main method. Run the program. Voila, what we have is we actually have what we have asked for. We have everything printed out as if it is a multiplication table in a math book, right? In an algebra book. Great. Now, issue is this is inside main, and we said we don't want to see any logic inside main besides the logic that will control the flow of the program. So we have to take it outside the main, and we are going to do another encapsulation. So we need to take this logic, put it inside a capsule called a method, and let's call this method public static void multiplication table. Great, perfect, right? Now take this logic out of here, cut it, paste inside this method, and you got yourself an encapsulation. So now when I call this method, not our first method that is more specific to a single line, but this new encapsulated logic that is specific for the multiplication table from 1 to 10, when I call this method multiplication table and run my program, I will get this table. And end of main is coming from my print statement. Let's remove this and let's see that our console is actually how we want it to be. Now we don't need no test values at this stage because our method simply prints out multiplication from 1 to 10. So we cleaned it up. We're gonna need to add some java.comments here. Do so, please. Okay, definitely add some java.comments, and let's maximize our console a little bit. Run the program again. We got this. So this was perfect demo of the concepts called encapsulation and generalization while developing methods in Java. This was a part of incremental development series. In the first video related to incremental development series, we looked into concepts of breaking down challenges into small pieces, creating pseudocodes, analyzing, and then starting to code in Java. We did that in this demo as well, in this and the previous video as well. We first of all broke down this code into small pieces. We printed out, we found out, we solved it for each single multiplication. We found out how we can solve it, how we can create a loop to print out, for example, multipliers of 4, multipliers of 3, multipliers of 2. And then we encapsulated that logic, and we generalized that logic in such a way inside this method so that we allow our invocation to pass in a value, to pass in an argument, so that the whole thing can be printed out. Okay? You can go ahead and generalize our method here even further. This multiplication table method can be generalized even further. Right now, this method only prints out multiplication up to the value of 10. However, why not do it 20? If you run this is going to give you multiplication of numbers up to 20, right? You might need it. Why not do it up to 100? This is going to give you all the multiplication up to 100. For Java, using a loops, this is a piece of cake. This is actually, if you read our content materials, we said that this was actually the initial feeling of those who worked with tables, that computers are going to do these things very easily. Because when humans do it, they tend to make mistakes. But computers, on the other hand, they do not make mistakes, as long as they're tested for one operation, and that operation is going to be repeated millions of times without a mistake. Go ahead, generalize this multiplication table method in such a way that it doesn't only work for multiplication of up to 10, so that you can pass in a value here, you can pass in an argument here, defining how further away this multiplication should proceed. Also, do not forget to experience or experiment with your code. Write the code, change something here. What will happen if instead of saying less than or equal to 10, you call the number variable again, right? Less than or equal to the number that is being passed. If I run this code, something like this happens. We have talked about this triangle inside our content materials. I'm not gonna spend more time. I'm going to save you some time so that you can go ahead and experiment it on your own. One more thing. Let's see, for example, let's take it back. Let's put our code back to working case. Now, you see how they are not in order. What if I add, instead of space, I add a escape sequence that adds a tab? Let's run it. How about this? Does this look better? You see? So do experiment, do put your knowledge up to now in use, play around. You can even you can even create this in such a way that they are even separated by a pipes. So it will look like a table. It will look like an Excel table. In the bottom, you'll have a lot of underscore characters that will close the bottom. In top, you'll have the same. On the left and right hand sides, you'll have pipes, and this will look like a table. Please have fun, explore, experiment, break, then always keep a good working code on the side. When you break in such a way that you can't fix it, just take the working code, paste it, and we will see that concept in development as well down the road. Right now, all we want to encourage you to do is practice, break, fix. Thank you very much for your time. We'll see you again in our next major topic.